Hi there, welcome to my channel. I'm glad you're here and I hope you get a chance to check out many more of my videos. If you like what you see, please make sure to subscribe below and also give me a thumbs up. If you have questions about any of the math that's on the videos, please leave those in the comments as well and I will get back to you. Believe it or not, I will send you a note. But I really do want to help students understand the math. And this is also a great way for teachers if you need a lesson plan, especially when you are out for some reason. You can use these videos for that. So again, leave comments, subscribe, thumbs up if you like it. Please don't give me a thumbs down. But anyway, I hope I help out. Take care and go Seahawks. See you later. Okay, so we're going to play this video first of this particular system being solved graphically, and then we'll come back and solve this algebraically, which you'll see me referring to also in the video. So here we go. Hey there, so I thought since I just did another intro video to throw in here, I would just go ahead and leave my face on because occasionally I should be visible, but I'm not always. So what I want to do on this one, this is 1-46 of lesson 1.1.4's review and preview. And I'm going to go ahead and use this Desmos homework help tool because that's exactly what you could be doing as well. And I'm going to go ahead and put these equations in two separate lines. Now you could also do this in the Texas Instrument Calculator, but be very careful because when you enter the negative from this negative 4x plus 9, they have a negative button and a subtraction button. And sometimes students get frustrated because they think just using that subtraction sign like most calculators and most computers do, they have a separate button for it. So it's in the bottom right, sort of. It's kind of bottom center, but you can see it from there. So let's go ahead and put these in because what we're going to do is we're going to show how these intersect graphically. Then I'm going to leave this video and go to a slide and show you how we can do it also with algebra. Because when they tell you they're solving for an intersection point, they're solving a system of equations. And so our two equations here are a system. So let's go ahead and just type it in. I'm going to do f of x here, and that equals 3x minus 5. So there's one line, excuse me. And then I'm going to come in here and I'm going to add the g of x. And I'm going to type negative 4x minus 9. Plus 9. Okay, here we go. All right, so we have our intersection point. And if I come over here and hover it and click on it, you'll see that it is 2, 1. So now what we're going to do is we're going to exit this video, and then we're going to go and look at how we solve this algebraically with a system. So hope that helps. See you very soon, probably like a second. Okay, so on this particular thing, you just saw that we graphed them both, and you see right here that we graphed them both, and we left them as f of x and g of x. But we're going to change those so that they're equal to each other. Y equals 3x minus 5, and then y equals negative 4x plus 9. Okay, so now that they're both equal to y, if I was in my classroom right now, I would say, okay, since both equations equal y, then they equal each other, is what everybody would yell out, hopefully. Okay, so we would set them equal to each other then. So 3x minus 5 equals negative 4x plus 9. And we are trying to get them to 2, 1, which is what you see circled there. Now, first thing I'm going to do is add 4x to both sides. So it's going to be 7x minus 5 equals 9. Then I'm going to add 5 to both sides. 7x will equal 14. Divide by 2, x equals 2. Then I take that 2 and I can plug it into either equation. But I'm going to just go ahead and choose this one for now. And I'm going to say y equals 3 times 2 minus 5. And that is 6 minus 5, which is 1. And if we did the same thing up here, we could plug in negative 4 times a 2 would give us a negative 8. And then add a 9 to that and get a 1. So our system is solved. And our intersection point is set at 2 and 1. And we just verified it algebraically, but also graphically in the video. Oh, hope that helps. Let's move on. Okay, so this particular problem is going to give me an opportunity to also teach you something that I love called outer over inner. So we'll start, I'll write that down down here, outer over inner. And this is another way to divide fractions, just so you know. So I'm going to go ahead and plug this in. To me, it's simpler, and with some of the concepts that come in down the road that are, heavy fractions, like if you get into trigonometric identities and things like that, there's some pretty heavy equations that you have to solve that are in fraction form. But what I'm going to do is I'm going to go ahead and plug this in. So f of 1/2, okay, equals 1 over 1/2. Okay, so what I'm going to do is I'm going to change that 1 to 1 over 1, because that's what it equals. Then I'm going to do what's called outer over inner. You will see a pattern on this. So I will do A and B for you, and then we'll talk about C and D briefly, and then you can go ahead and figure that one out. I'll put the answers there in a moment, but let's talk about this. So now I've got a fraction over a fraction. So what I'm going to do is I'm going to multiply my outer. So that's 1 times 1, 2. So that's going to be 2 over, okay, because this is the over, my inner fraction. So this is my inner, 1 times 1. So that means this one will equal 2. So f of 1/2 equals 2. So let's do that again on this next one. So I've got f of 1/10 equals 1 over 1/10. You're pretty much realizing that if you're doing 1 divided by any fraction, it's just going to flip that number. But this is just something to help you with. So I've got, again, outer. So my outer is 10 over my inner, which is 1. You notice that you're just flipping it. So the f of 1/2 on this equation was 2. The f of 1/2 on this equation is 10. So you're going to see a pattern. Okay. Now, on these two, I just write them as decimals because the f of 0.01 equals 1 over x. Okay. Well, let's just put 0.01. I'm going to write it as a fraction. This is 1/100th. So it's f of 1 over 100. This one is f of 7 over 1,000. Okay. So what I'm going to do is I'm going to have you stop the video right now. Go ahead and solve those two. Use whatever method you want, because this will be 1 over 100, and this will be 1 over 7 over 1,000. Okay, so go ahead and take a moment to solve those, and I will help you. Okay, I'm back. Hopefully you paused it. If you didn't, you didn't. Okay, so again, I turned this into a fraction. I didn't give myself a whole lot of room. So my outer over my inner, which is 1 times 1. Okay. This one also, I'm going to put it over 1. So my outer over my inner. And I would typically just have you leave it that way. This is an improper fraction. You could turn it into a mixed number or a decimal. It will depend on what your teacher's expectations are in your class. So hopefully that helps. We will now move on to the next problem. Remember, if you have questions, you can leave questions in the comments section of the video. Here we go. Okay. So this is 1-48, and if you can tell, I've been doing everything in lime green and navy blue. That's because I'm a Seahawk fan. Go Seahawks. Sorry, that annoyed you. That's just my thing at this time of the year. Okay, so we have two quadratics here, and I've also placed images of what the graphs look like. The solutions, and so when you're solving, this is just a reminder, it's always where they intersect the x-axis. And so on the blue one, we'll talk more about that later because you see these crazy numbers here. That's because you can't really factor this one. There's not two numbers that multiply to a negative 12 and add up to a negative 5. So you're going to have to use a quadratic formula. So we'll do that in a minute. Let's do this easier one first. So remember, I have AC up here, and I have B here, down below. Okay, so in this equation, my A equals 1. My B, because this should be a 1 up here, my B equals negative 8, which is right here, and my C equals 15. Okay, this, and some of you are already at it. You already know what to do. You know how to guess and check. You can figure out a method, which is totally fine. You can do that. That's no problem. But for some people, you just need a method to prove it. Now, if I'm correct, my point should be at negative, wait, that's 2, okay, that's 3, 0. And then this is 5, 0. So let's see if my factoring is correct. Sorry, I made that font so small, it was difficult to read. All right, and then you got to be able to look at the scale and all that good stuff. So here we go. My A times C in this case, which is A times C, is 15. And my B is negative 8. And so I have to come up with two numbers that multiply to 15 but add up to negative 8. Well, the first thing I always go to is the facts that I know. Well, I know 1 and 15 are that. That's not going to happen. I know 5 and 3 are 15, and I know somehow 5 and 3 can be 8. But in this case, we have to be really careful because 5 times 3 is a positive 15, but 5 plus 3 is a negative 8. So the way to still have a negative or a positive 15 and a negative 8 is to make them both negative, which means I'm going to factor this, and it's going to be x minus 5 and x minus 3. Now, again, remember, it's whatever makes these parentheses equal 0 is your solution. Well, if I was to put a 5 in for x minus 5, it would equal 0. So x equals 5. That proves this point, 5, 0. And then on this one, it would be x equals 3, because if I put a 3 in, it would equal 0. And that proves that point. So that's the easy one. All right. Now over here, we still have to do the A, B, and C, but we have a quadratic formula. And so we're not going to end up with decimal answers because I'm going to leave it in what's called simplest radical form. And I'll show you what that is by the time we're done. So my A on this one is 2. My B equals negative 5. And you're like, why are we doing this if we're not doing the diamond method? Well, because if you look up here at this formula, I need to know what A, B, and C are. And C equals negative 6. So I'm just going to plug them all in. X equals, and it's going to be a negative 5. Okay? Plus or minus underneath a negative 5 squared minus 4 times 2 times negative 6, which is really difficult to get in here. So I think I'm going to cut off my parenthesis there. All right. Now I'm going, and that's all over 2 times 2. Okay. So let's just start by simplifying it a little bit more. A negative 5 is positive. Okay. Then underneath we have a negative 5 squared, which is 25. And then we have minus 4 times 2 times negative 6. So negative 4 times 2 is a negative 8 times a negative 6 is a positive 48. Okay, all over 4. All right. X equals 5 plus or minus. Well, if you add 25 plus 48, you get 73. Okay, and then you're dividing by 4. So you could leave it here because this does depict two solutions, and this is simplest radical form because 73 is a prime number, so I can't break that down any farther. Or if your teacher wants you to, you can say here's one solution, 5 plus square root of 73 over 4, or 5 minus the square root of 73 over 4. And that is the final answer. If you were to plug in 5 plus root 73 plus 4, you would end up, divided by 4, you would end up with the fraction that you have here. And if you did 5 minus, you would end up with this decimal here. Not the fraction here, I'm sorry. This is a decimal. and you would end up with the decimal there. So that ends 1-48. Hope that helps. There will be a link at the end of this video for quadratic problem solving that deals with factoring and the quadratic formula. So it will be up to you if you want to watch that and get a little bit more help. There are good examples on that, and it'll walk you through a few more. So that's 1-48. Okay, so on this particular problem, they actually give you a homework help thing, and that's how I got my little graph here. I moved the points to where they need to be at -5, 0 and at 0, 3. But now the first thing it says, plot the points and find the distance between them. Give your answer both in simplest radical form and as a decimal approximation. Now we could use a distance formula, but we are just going to use the Pythagorean theorem on this one because we can use a right triangle. All right, so we're going to use the Pythagorean. So that's, again, if you don't remember what that is, it's a squared plus b squared equals c squared. This can be our a, and then we'll make this our b. So we're looking for c, okay? So I'm going to put 3 squared plus 5 squared. Notice I didn't put -5 even though it's going in that direction because distance can't be negative. You could plug it in, but it would still end up being a 25 if you were done anyway. So that equals c squared. So we've got 9 plus 25 equals c squared. And that's 34 equals c squared. So in the simplest radical form, c equals the square root of 34. And that's because you can't simplify the square root of 34 anymore because there's no perfect square that is a factor of 34. So, and then the decimal of that is, just a moment, it is 5.83. It goes on for quite a bit. So let's say 5.83095. I'm just going to leave it at that because it's already rounded. If somebody said, give it to me in the nearest hundredth, it would be 5.83. That's the hundredth. If someone said nearest tenth, you would give it to them in 5.8 because remember we round up when the next number is 5 or greater. We round down if it's less than 5. So that's our decimal approximation of 5.8. So you could say square root of 34 or you could say 5.8, which is really a good thing because let's just remind you of this. C has to be the bigger side. So if I got a number that was less than 5 or 3 here, then I would have there'd be a wrong answer is what I'm trying to say as I stutter through this. Okay. Then the last thing that we need to do on this one is figure out what the slope is. And I'm going to switch to a different color so it's easier to see since I've already written all over this graph. This is going to be a positive slope because it's going up to the right. So I'm going to start, and it's because of this 3 over 5. I'm pretty sure that it's going to be up 3 over 5, and that's our slope. So let's go up 3 units, and then let's go over 5 units. Rise, over run. So our slope equals 3/5. Very good. And just to add to that, if we were to actually come up with an equation for this one, it'd be in slope-intercept form. If this helps as a little review, we have y equals our slope of 3/5 x, and then our y-intercept is 3. So that would be our y-intercept equation also for that hypotenuse. All right, that ends 1-49, moving on. Okay, so these two questions are actually pretty quick, so I'm just going to touch on them. You know, this is probability. 1-50 is just probability. So Stacy says to Corey, reach into the standard deck of playing cards and pull out a card at random. If it is the Queen of Hearts, I'll pay you $5. What's the probability that Corey gets Stacy's $5? Well, there's 52 cards in a deck. Okay. And only one of them is the Queen of Hearts. As I do a little abbreviation there. Okay, so that means that's only going to be 1 out of 52. Now the next one says, what's the probability that Stacy keeps her $5? Well, that's easy. If there's 52 and one of them out of 52 is the Queen of Hearts, that means, and I guess I shouldn't say it's easy, because if you're struggling with this, it's not easy to you. But if 1 out of 52 is how many Queen of Hearts, what's left out of 52 when you take out 1? 51. So 51 out of 52 is what the odds are for her to keep her $5. Well, pretty much, unless he's pretty good at picking cards, it's Stacy's going to be keeping her money. So anyway, on the next equation, it says find the error in the solution at the right. And identify the error and solve the equation correctly. Well, if you're looking through this and the 4.1 is subtracted, that means the error is happening here, okay? Because if you subtract 4.1 from the left-hand side, so let's write this out. Okay. And I've got lots of commentary in the background, so I'm sorry about that. But we're going to go ahead and just do the best we can here. So if I subtract 4.1 from each side, I'm going to have 0 equals 5.4x plus 23.7. So you can see at this point where the mistake was made. And so instead of being 5.4x equals 23.7, we should have 0 because of the 4.1 being subtracted. So then what we do is we subtract 23.7. So you end up with 23.7 equals 5.4x. And then we have to divide by 5.4. Let's see if I can write that better. Oh my goodness, I'm just being so messy. And when we do that, we get x equals, I'm going to kind of go over here. It's a little messy and a little quick, but it will equal a negative 4.4 if you round to the nearest tenth. All right. And that helps with 50 and 51. Let's move on to our last problem. Okay, so these two, you should actually just stop the video right now and try to solve them. And then you can come back and you'll see the work. Okay, and I will walk you through the problem. So on this first problem, what I'm going to do is I'm going to add 2.1 to both sides. Okay, and so it's going to be 3.9x equals 11.2x. And then when I add that 2.1, it's going to be 53, so plus 53.8. Okay, then I'm going to subtract, because I'm trying to get all the x's on one side, 11.2 from both sides. So when I do that, if you did this correctly, you should end up with a negative 7.3 on the left, and then 53.8. And then, of course, you're going to divide by negative 7.3. Because that cancels that out. So your x will equal to the nearest hundredth a negative 7.37. So hopefully you got that correct and you understood the process. This next one's a little tricky, but given the denominators of 1/5 and then the 13 over 25, I think the easiest thing is just to convert all of them to decimal. So 1/5 x would be 0.2x minus 2. Equals, and then if you do 13 divided by 25 on the calculator, you get a 0.52. And then, of course, this is already in decimal form. I probably should put a 0 in front of that too. 0.7x. Okay, so we just solved from there, okay? So what I'm going to do first is I'm going to add 0.7x. 0.7x. Oops. I was getting that messy. And so that leaves me with 0.9x minus 2 equals 0.52. Again, I probably should put a 0. And those cancel out. So then what I've got to do is add 2 to the other side. So it's going to be 0.9x equals 2.52. And then the last thing I have to do is divide by 0.9. And so x equals to the nearest tenth 2.8. So hopefully you figure that out and you understand that. And that ends lesson 1.1.4's review and preview. And just like I said in the beginning, if you are someone who likes these videos, please subscribe below, give me a thumbs up. And if there's any questions about any of the math that's in this video, please leave your questions in the comments and I will get back to you. And we'll see you at the next video. Take care.